Hello and welcome to your review warm-up. So let's take a look at our questions here and we'll see how we do. According to the Mars Candy Company, 20% of its plain M&Ms are orange. Assume that the company's claim is true. Suppose you reach into a large bin of plain M&Ms without looking and pull out 8 candies. Let X equal the number of orange candies. What is the mean and standard deviation of X? All right. So in this case, we are pulling out a fixed number of trials. So we have a fixed number of trials, and we are counting the successes, which tells us that this is a binomial situation. All right. Binomial is where we have a fixed number of trials, and then we're counting how many successes we achieve. So when it says, what is the mean and standard deviation of X, our formula for the mean of a binomial distribution is N times P, where P is the probability of success. And our formula for the standard deviation of a binomial distribution is the square root of N times P times Q. All right, so our N was 8. Our probability of success was 20%. So that means our mean is 1.6. And then our standard deviation, I can't do that one in my head, 8 times 0.2 times 0.8. All right, number of trials, probability of success, probability of failure, because those two always have to add up to 1. So we've got the square root of 8 times 0.2 times 0.8 equals 1.13. All right, so there's our mean, there's our standard deviation. What is the probability of pulling out 0 orange candies? All right, so when we're looking for the probability of a single event, that's binomial PDF. We have 8 trials. The probability of getting an orange is 0.2, and we want to know what are the odds that we get 0 successes. Now, you don't even really need to use BPDF on this one, because normally what makes the binomial tricky is figuring out how many combinations there are. There's only one way you can pull out 0 orange candies. All right, so it basically just means that you failed 8 times in a row. So there's an 80% chance of not getting orange. It happened 8 times in a row. You're going to see that these are going to give us the same answer. All right, so if I do 0.8 to the 8th, I'm going to get 1677216. If I go to my distribution menu and I go to binomial PDF and I say there are 8 trials, there's a 20% chance of getting orange. What are the odds I get 0 orange? All right, you get the same exact answer. So these are both going to give you, regardless of which one you do, 0.167772216. Now again, this only works because there's only one combination to get 0 orange candies. Normally you just have to use the BPDF because there's going to be multiple combinations. So again, this is just kind of exclusive to this one, but they do give you the same answer. Next one says, what is the probability of pulling out no more than 4 orange candies? So that's another way of saying pulling out 0, 1, 2, 3, or 4. So we could do a PDF of all 5 of these and add them together. All right. Or this is what binomial CDF is meant for. All right. Binomial CDF, when there's 8 trials and there's a 20% chance of finding one. All right. When we put 4 here, this is basically saying less than or equal to 4, which is exactly what we want. So again, we can go to our menu, binomial CDF, 8 trials, 20%, and we want to know 4 or less. And we get a probability of 0.9895936. Okay. Next, we have what's the probability of pulling out at least 4 candies. So that means 4, 5, 6, 7, or 8. Now again, we could do each one of these individually, PDF of 4, 5, 6, 7, and 8, and add them together. Or we could take advantage of complements and say to ourselves, all right, well, if I want to know 4, 5, 6, 7, and 8, what I really want to do, 0, 1, 2, 3, 4, 5, 6, 7, 8. What I really want to do is just get rid of 0, 1, 2, and 3, and then whatever's left over will be 4, 5, 6, 7, and 8. So we write that as 1 minus B, C, D, F. And even though this says 4, we do 8, comma, 0.2, comma, 3, because we're subtracting away 3, 2, 1, and 0, so that 4, 5, 6, 7, and 8 is what we have left over. So 1 minus binomial CDF, 8.2, and then 3. And we're left with 0.05628816. Right. Number 2. A large roulette wheel is divided into 12 equal sections. 9 of those sections you lose. 3 of those you get triple your money. What is the mean number of times you will have to spin before winning? What is the standard deviation? All right. So we're counting attempts. All right. We're not counting successes. We're counting attempts. So that tells us that we're using the geometric. And for the geometric sequence, our mean is just 1 over p. And our standard deviation is the square root of q over p squared. All right, so again, formulas that you just have to be comfortable with and be able to identify the scenario and then apply the correct formula. So if there's 12 equal sections and you win on 3 of those, you basically win on 3 out of 12, which is 1/4. So we're basically looking at 1 over 1/4. Again, that's the 3 out of 12 reducing to 1/4. Or put another way, 4. All right, the mean number of times we're going to have to do this is 4. And then for the standard deviation, if P is 1/4, that means Q is 3/4. And we're dividing that by 1/4 squared. All right, so that's 1/4 squared. So again, this one, I'm just going to write it as 0.75, because that's 3/4, divided by 0.25 squared. And then I'm going to take the square root of that. And I'm not going to take the square root of that. I'm going to take the square root of that and get my answer there. So 3.4641. All right, so in both cases, it's just plugging numbers into formulas. You just have to be able to identify the situation and then use the correct formula. All right, what is the probability of winning on the 4th spin exactly? So that would be geometric PDF, because you're doing it for a single event. So geometric PDF, again, if we go to our distribution menu, there it is down there at the bottom. Our probability of success, we already said, was 0.25 or 1/4. And we want to know what are the odds of winning on the 4th spin. So we've got what we have here. We had a 0.25% chance of winning, and we wanted to know the odds of winning on the 4th spin. and that worked out to be 0.1054687. I don't know why I'm writing out all the decimal, but I am. All right. Now, again, geometric, there is this PDF, but it's really a very simple calculation. It's just saying that, okay, you failed the first 3 times. So you failed once, you failed twice, you failed 3 times, and then you succeeded your 4th time. All right? Or put another way, it's 3 to the 4th to the 3rd times 1/4. All right? And you're going to see this is going to give me the same exact result. So if I do 0.75 to the 3rd power, and then I multiply that by 0.25, I end up with the same exact answer. So again, you're welcome to use geometric PDF. There's no problem with it, but it's really a pretty simple calculation that it's doing. Number 2 here, what is the probability that it will take 3 or more spins to win? So that's saying like, okay, 3, 4, 5, 6, all the way up to whatever. I mean, we don't know how many spins it could in theory take. So in this case, what we need to do is we need to subtract away. Well, there is no 0. Sorry, that's a binomial thing. You can't win on your 0th spin. We need to subtract away 1 and 2. And then if we subtract away 1 and 2, what's left over is 3, 4, and 5. All right, so we could say 1 minus G CDF, where there's a 0.25 chance of winning, and we're going to subtract away 2 and 1. Because if we subtract away 2 and 1, we're left with 3, 4, and 5. So 1 minus geometric CDF, 0.25, 2, and we get 0.5625. All right, what is the probability that you will win within the first 5 spins? So that's basically saying 1, 2, 3, 4, or 5. That's exactly what geometric CDF does, right? We could PDF all 5 of these and add them together, but that would be silly. So geometric CDF, when there's a 0.25 chance of winning, and we want to know what are the odds of winning in the first 5 spins. So again, GeoCDF, 0.25, change that to 5. And we get 0.7627. We'll round it this time. All right, so again, being able to identify binomial or geometric and then apply the correct formulas or use the correct tool on your calculator, the correct distribution to get your probabilities. All right, let's take a look at the back here. In a game of 4-spot Keno, players pick 4 numbers from 1 to 80. The casino randomly selects 20 winning numbers from 1 to 80. The table below shows the possible outcomes, the probabilities, and net results of placing a $1 bet. All right. So basically, if you get 0 matches, there's a 30% chance of that happening and you lose $1. If you get 1 match, there's a 43% chance of that happening, but you lose $1. 2 matches, there's like a 20% chance and you break even. 3 matches happens only 4% of the time, but you make $2. And if you get all 4 matches, which doesn't happen very often, you could make $119. So what is the expected value? What is the standard deviation? So when we're doing this, this is one that we're going to put into our calculator. The payouts are going to be L1. The probabilities are going to be L2. So I've already got it entered into my L1 and L2. There's my payouts. There's my probabilities. I'm not using matches. That's just telling me the rules of the game. That doesn't have any relevance to like actually calculating the mean or standard deviation. I just need the payouts and the probabilities. Then I can go to stat calc, 1 variable stats. My list is L1, that has my payouts in it. My frequency list is L2, that has my probabilities. And when I hit calculate, I'm going to see, so again, we're running one var stats, and then just make sure that you use the frequency list as L2. All right. So my expected value of X is negative 0.298. My standard deviation of X is 6.5808. All right. So anytime we have one of these charts, finding the expected value or the standard deviation, you're pretty much going over to your calculator, putting them into L1 and L2, and then running one variable stats, specifying the frequency list as L2. Right? But then we can get both of those values. Now, it says if you were to place a $5 bet instead of a $1 bet, how would that change your mean and standard deviation? So, effectively, that's like multiplying by 5. If you go from a $1 bet to a $5 bet, it's multiplying by 5. And we learned that when you multiply by a constant, both the mean and the standard deviation get multiplied by that same constant. So our new mean would be negative 0.298 times 5, and our new standard deviation would be 6.5808 times 5. All right, so negative 0.298 times 5 gives us negative 1.49. Our new standard deviation would be 6.5808 times 5, 32.904. All right, so again, in both cases, we're multiplying both the mean and the standard deviation by that same constant. All right, the second one here says instead of one $5 bet, what if you played 5 $1 games? How would that change your mean and standard deviation? So now we're not multiplying, now we're not adding constants, we're adding random variables. We're just saying, all right, if you were to play this game 5 times, what does that do to your expected value? What does that do to your standard deviation? So for the expected value, or the new mean, we would just be taking those numbers, the negative 0.298, and adding it together five times. Now, whether you add something together 5 times or whether you multiply it by 5, you're going to get the same answer. All right, so this is still going to be negative 1.49. All right, that doesn't change. What changes is the standard deviation. All right, when we're combining random variables, we actually have to add the variances. So what that means is we're taking this 6.5808 and we're squaring it. And we're taking this 6.5808 and we're squaring it. And we're doing that 5 times. So that's 3. That's 4. That's 5. Now, by turning it into variances, that's great. It's no longer a standard deviation. It's a variance. So the final step is after you add those all together is to take the square root again so that we're back as an actual standard deviation. So I've basically got 6.5808 squared plus 6.5808 squared plus 6.5808 squared. Now, if you're asking yourself, can you just multiply this by 5? Yeah, you can. All right, it's going to give you the same answer whether we add it together 5 times or whether we multiply it by 5. You're going to get the same answer. All right, there's me adding it together 5 times. There's me taking the one answer, multiplying it by 5. You get to the same place. That's the combined variance. Now we have to take the square root of that to get our final answer, which is 14.7151. So 14.7151 would be our final answer there. All right, so there's our combined mean, which is the same as when we multiplied by 5. There's our combined standard deviation, which is less than we multiplied by 5. So means end up being the same, but this one has a lot less variation, which makes sense. You know, if you play the game 5 times, you've got a better chance of getting like one win and a whole bunch of losses to help balance things out. If you just play once on a $5 bet, the win is bigger, but the losses are also bigger. So you're going to get more variation in your results. All right. So I hope this was helpful. If you have any questions, just let me know and we'll go from there. All right. Bye.